Okay, thank you very much. Thank you very much to AFCA for the invitation. As has been said, I'm Simon Hodson, Executive Director of CoData, which I'll go on to say a little bit more about CoData, but it's an interdisciplinary body, as we call it in the jargon of ICSU. So we work under the umbrella of ICSU, the International Council of Science. And I'm going to talk about big data, in part because that's what I was asked to talk about. Inevitably, I'm going to talk about data as such as well, and big data as a type of data, and I'll talk about CoData, and as was on the blurb for the seminar, talk about what CoData is doing generally, but specifically what we're trying to do in the arena of big data. So, as has been said, big data is a buzzword. What do we mean by big data? You've probably heard of the 3 V's, volume, velocity, and variety, and they're a pretty good definition. And I would contend that any other V's that you've heard of really are purely marketing for big databases, for solutions. The challenges exist in volume, just the sheer size of data, the rate at which it's being created, and the growing variety and complexity of data. And because it's associated with marketing and selling database solutions, there's some skepticism in the scientific world about big data as a useful term. And yet, by the same token, there's a great deal of interest in it, and it's being used for grant applications and for funding programs. So we have to be careful as researchers, as scientists, in the way we use the term and the way we define it. But I think there's growing consensus that it is a useful term, that it does say something about the age in which we're in, just as data-intensive science says something, or said something still, about the age in which we're in. And it says something about the challenges that researchers, in particular scientists, because I'm speaking from that perspective, are facing. Technical, economic, to do with the sustainability of data infrastructure, and cultural challenges as well in the way that science and research are conducted. Clearly, we've got many examples of major projects producing huge volumes of data. If you're playing big data bingo, then that's the first one. The obligatory photograph of a large telescope array, that's the synoptic telescope array, which is being built in Chile at the moment, which will produce terabytes upon terabytes of data per day. At a recent conference that CoData organized with our sister organization, the ICSU World Data System, Citation Baru, who's the new data head at the NSF, at the National Science Foundation, gave one of the keynotes. And he stressed that, yes, in terms of this definitional issue, big data is about big, it's about some of these challenges, but it's also about data. We've got to remember the science, and we've got to remember some of the core data principles which underpin data as such and must still underpin big data. So there will be disciplinary and interdisciplinary challenges. There'll be issues about knowledge and validity. How do we demonstrate proofs effectively in this big data world where algorithms are being used to extract information from vast and diverse data sets? How do we demonstrate these proofs effectively? There's a challenge of education and training, which Carol mentioned earlier. There's also issues about ethics, which is particularly important, of course, with data relating to human subjects. So these are part of the challenges that we're facing. You may be familiar with this new report, The Data Revolution, which was produced by the Independent Expert Advisory Group on the Data Revolution for Sustainable Development, part of a UN advisory group, issued a few weeks ago. And I mention this because it's one of a number of reports, but it's particularly it's short, it's forceful, it's up to date, and it's an interesting call to arms to use the data at our disposal. It observes, as many reports have done, on the huge growth in data, as I said, not just in volume, but in the types of data at our disposal for research, and particularly for research about development. And it calls for that variety of data to be used effectively, and argues that there's a huge opportunity which needs to be taken, but only if certain challenges can be addressed. And clearly those are to do with data inequality, the uneven availability of data, and the uneven ability, capacity, probably a better word, to use those data. And issues about trust, privacy, which I've already mentioned, data quality. This was back to Citan's point about the traditional data science challenges, but also about data integration and the integration of different types of data. For example, Earth observation data, mapping of various types, analysis of land use with socially related data about the human societies which are using those land and the economic data relating to those land use. Why is that sort of data important? I'm going to mention now a program which is sponsored by ICSU, the International Council of Science, among a number of sponsoring organizations called Future Earth. I don't know how many people here have heard of this program, an overarching 10-year interdisciplinary research program to provide a focus for interdisciplinary research on global change in the broadest sense. Not just climate change, but also social and economic change in relation to climate change and ecological change, etc. To some extent, it's some house cleaning on ICSU's part. It brings together some of the existing global monitoring programs on ecology, on climate change, but also adds to those a broader dimension, taking in the social and the economic aspects. And therefore, again, I would argue in this big data world, it faces a number of specific challenges about data integration and about the integration of different data types. So again, the Earth observation data, which is of importance to global monitoring, the models which come out of that, but also new observations from new technologies and the sort of data which hasn't always been incorporated into this sort of research, so the social and the economic data. And so what I'd like to argue is our challenge in big data is not just to do with volume, it's to do with this intense complexity and how we integrate those diverse data types to answer important questions about the global future and global sustainability. So that's a little bit of definitional stuff. I'm going to move on now to talk about CoData, really give you an introduction and an overview of what CoData does, and then come back to some of the activities we're doing to address those big data challenges that I've mentioned. So CoData, it stands for the Committee on Data for Science and Technology. As I've said, we're part of the ICSU family. We work under the umbrella of ICSU, the International Council of Science. ICSU has the mission to strengthen international science for the benefit of society, and we support that mission specifically by promoting improved scientific and technical data management and use. We've actually been around for a surprisingly long time. CoData was founded in 1966 by some quite visionary scientists who even then were encountering issues about data availability, data quality, and indeed data volume. I'm not going to read all that out, but it's interesting that they talked in their terms with the technology that they were using at the time of a data deluge. Within the CoData mission and our strategy, we have 4 areas. We work in the area of open data policies. We work on data science, and that's where we tackle some of the big data issues. So frontier issues, as we call them in data sciences. What are the big challenges in data science? We work on capacity building, and we work on international collaboration. I'll run through those strategy areas quickly. So open data policies, we provide expert reports, we organize workshops for the ICSU community and the broader community. We've contributed to, for example, to the recent ICSU report on open access for literature, for data, and the use of metrics. We've been very supportive of an organization called GEO, the Group on Earth Observation, because Earth observation and the availability of the Earth observation data has been very important internationally. In our recent General Assembly, we elected a new president, which is Geoffrey Bolton, who chaired the Royal Society report on science as an open enterprise. And we're looking forward to the next 4 years under his strategic leadership, really to take forward the points and the mission which is laid out in that Royal Society report to an international level. CoData does a lot of its work through task groups, and we've been very much involved in pushing the agenda on the citation of data and the incorporation of data as a first-class object, as the jargon goes, in the literature, and to do so by effectively citing that. The CoData ICSD task group on data citation has been going for the last 4 years, organized an important workshop for attribution, then produced a report, Out of Sight, Out of Mind, and then contributed to a large community activity for the Joint Declaration of Data Citation Principles. I mentioned challenges in data science, and again, this is an area where we work largely through our task groups. Just to mention 3 in particular which relate to challenges in big data, a group working on linked open data for global disaster data, drawing diverse data sets, integrating them using linked open data approaches. They're currently working on a white paper on that methodology. A task group looking at global roads data. What are the methodologies you need to make data sets of road positions from satellite imagery, but also incorporating, again, other data sources, including crowdsourced data. And they've produced a set of global roads data, which is open access from that sort of approach. And another task group on advanced informatics for microbiology, integrating, again, diverse data and information, extracting information from patents and from culture collections, and integrating that with the literature. CoData has a data science journal, and I'm unable yet to announce, but we will very soon be relaunching that on a new platform, so please watch this space. I wanted to mention this working group as well on nanomaterials, just as an introduction to the way that CoData often works with our community. Like ICSU, we have national membership, and we also have membership from international scientific unions. And we work with those unions and with the data committees, which those unions often have, on particular issues. And this is an example of that. We convened a workshop on the challenges for describing nanomaterials and the data about nanomaterials, developed that into a project with ICSU's support, which led to this framework for description of nanomaterials, which has been published as a result of that activity, and is now being refined and validated in the context of a broad European project. So there's a modus operandi there which we're trying to apply to a number of research areas, and we want to push into interdisciplinary research areas as well. Another area of activity is international collaboration, and here I want to start moving a little bit back onto the theme of big data. So we recently held in New Delhi, as I said, CIDATACON, Scientific Data Conference, International Conference on Data Sharing and Integration for Global Sustainability. And it's addressing that challenge of sharing, the availability of the data, but also the integration of data, how we integrate diverse data types to answer important scientific questions. So it's motivated by the conviction the most significant research challenges, and in particularly the pressing issues relating to global sustainability, cannot be properly addressed without due attention to various issues relating to data. So trying to raise data issues on the agenda for international science. As part of that program of international collaboration and addressing issues around big data, we organized in June a workshop in Beijing on big data issues, and specifically big data for international scientific programs. What are the big data challenges for international collaborative programs like Future Earth or IRDR, which is Integrated Research on Disaster Risk, for example? The principal output of that were the outlines for a working group, which we're currently in the process of setting up, and this statement on recommendations on big data, which I'll go through now. So we made a series of recommendations and outlined a number of actions which would be taken forward by the CoData working group. I've probably not go through these in excessive detail, but they really focus around this need to understand better the implications and the challenges of big data as they relate to science and research, and specifically as they relate to international collaborative programs working in interdisciplinary areas.
2 minutes.
Okay. And specifically the actions for the CoData working group to explore those challenges through case studies. And then finally, the closing segment, I'm going to talk about our capacity building work. This year we've organized training courses in Beijing, a 2-week training course in Beijing, and a shorter training course in Nairobi at the Jomo Kenyatta University of Agriculture and Technology. The workshop in Kenya was part of a broader activity. It was a shorter workshop, so it only touched on a smaller number of training areas. And it was part of a larger workshop hosted by UNESCO and supported by the Kenyan government to identify principles of preservation and open access to research data in developing countries. Those principles have been finalized now, and then we're following up with a set of guidelines on the implementation of those principles. As I said, the 2-week training course in Beijing was targeted especially at big data issues, but also at researchers from developing countries who we were able to get to come in for those 2 weeks. From 21 participants from 10 developing countries. And we intending to use this as a model for an ongoing series of training workshops, and I'll close on that. We're part of a Research Data Alliance working group to develop a reusable curriculum and to implement that curriculum in a series of what we're calling summer schools in developing countries. We're starting off with our partners in Kenya, and we hope to be able to extend that more broadly internationally. And with our partners in the Research Data Alliance, we're exploring funding opportunities and looking for partners and sponsors. We're working on the curriculum framework for data science and for data science as it addresses big data issues. The outline of topics there is very broad, but that's the sort of topics which were used in the Beijing workshop, and we intend to reproduce in a workshop that we're going to organize in March in collaboration with the Indian Statistical Institute in Bangalore. So back to India with partners there. That workshop is going to be largely targeted at Indian researchers and researchers from the region, from the SAARC countries, going to be modeled on the curriculum we used in Beijing, but with the input of the specific expertise from our partners there, and that's Devika Madali, who's from the Indian Statistical Institute. And here to close, really this, my message to this audience is we're looking for sponsors for travel of international experts. We're looking for experts interested in contributing to this sort of workshop. And the sort of things perhaps this community might be able to contribute are on data publishing, on big data and scientific proof, on those epistemological issues, and its relation to how that's communicated in the scholarly literature, and also big data and research ethics from a publisher's perspective. Thank you very much for your attention, and please come and speak to me afterwards.